Good morning. With this lesson, you will begin learning about polynomial expressions. The objective for this lesson is as follows. The student will, 1, identify the degree of a polynomial, and 2, arrange polynomials in standard form with 100% accuracy on checkpoint 1. This is the Common Core State Standard relating to today's lesson. First, we need to be familiar with some key terms and key concepts in order to understand the lesson. First, a term is a component of a polynomial expression that is either added or subtracted. A polynomial is a sum of monomial terms. A monomial is a polynomial with only one term. A binomial is a polynomial with exactly 2 terms. So a way to remember that is to notice and recognize the prefix mono, meaning 1, monochrome, monotone, 1 term, 1 tone. So monomial means a polynomial with 1 term, as in the word bicycle with 2 wheels. Binomial has 2 terms. Trinomial, like tricycle or trimester, is a polynomial with 3 terms. So that's a way to tell the difference between a monomial, binomial, and a trinomial. The degree of the term is the exponent of a term. The degree of the polynomial is the greatest exponent or the highest exponent in a polynomial. Standard form is the arrangement of terms based on exponents in descending order. So the highest or the greatest exponent goes first, and then it goes in descending order from greatest to least. Take a look at the first 3 examples that I have displayed here. It says, identify whether the following polynomials are monomials, binomials, or trinomials. Then identify the degree of the polynomial. So for example 1, I have the term 10z. Since there is only 1 term in that polynomial expression, that is a monomial. For example 2, take a look at that example and determine whether or not that's a monomial, binomial, or trinomial. Because there are 3 terms in that expression, first term, second term, third term, this is a trinomial. Looking at example 3, that is an example of a binomial because we have 1 term, the 7, and the second term, negative 2x. So example 1 is a monomial, example 2 is a trinomial because 3 terms, example 3 is a binomial. So now we need to talk about the degree of the polynomial. Back at example 1, remember the degree of the polynomial as a reference is the greatest exponent in a polynomial. So for number 1, the greatest exponent in this polynomial is 1. Remember, when you don't see a number, it's understood to be 1. So the degree of the polynomial for number 1 is 1. Take a look at example 2. What do you think is the degree of that polynomial? Remember, the degree is the greatest or highest exponent in a polynomial. The degree of the polynomial is 8 because that is the greatest exponent present in that expression. Looking at example 3, we already recognize that that is a binomial. So what is the degree of that binomial? The degree is 1. That is the highest exponent. Look at the next example set. For example 4, is that a monomial, binomial, or trinomial? In order to answer that, look at the number of terms present in their problem. All right, there are 3 terms, so that is an example of a trinomial. Now, what is the degree of the trinomial? The degree of the trinomial is 2. All right, looking at example 5, we can see that that is a monomial because that's one term present in the expression. Now, what is the degree of the polynomial? The degree of the polynomial is 0. 8 is an example of a constant. Constants always have the degree of 0 because there is no variable present. All right. Example 6, we have 2a cubed minus 3. What type of polynomial is that? Monomial, binomial, or trinomial? That is an example of a binomial because there are two terms. The degree of the polynomial, or the binomial to speak specifically, is 3 because the greatest exponent is 3. I'm going to talk about putting polynomial expressions in standard form. So as a quick review and reference, standard form is the arrangement of terms based on exponents in descending order. The exponents are going from greatest to least. Taking a look at the expression for example 7, we have x cubed plus 3x plus 3x squared plus 1. Looking at the exponents only, not the coefficients, but the exponents, we have 3, 1, 2, 0. What is the greatest exponent in this problem? That is 3. So x cubed should be first. Then following that, we should have plus 3x squared. And following that, we should have plus x. And lastly, we should have plus 1. Now, looking at the exponents, it's in descending order: 3, 2, 1, none. 3, 2, 1, none. Correction. All right. So now this expression is in standard form because the exponents are arranged from greatest to least: 3, 2, 1, none. Look at example 7. We have 2a cubed minus 3 minus 6a squared plus 5a. We're being asked to put this polynomial expression in standard form. So now we have to recognize what is the greatest exponent present in the problem. As a review, we have 3, 0, 2, 1. You only look at the exponents, not the coefficients. So the greatest exponent present in this problem is 2a cubed. So that's going to be the first term. Following that, you will have negative 6a squared. Following that, you will have 5a. And lastly, negative 3. The exponents are now arranged in descending order, meaning from greatest to least. We have 3, 2, 1, none. This is our expression in standard form. Remember, the expressions in standard form, meaning that it is arranged by the exponents going from greatest to least. Example 9, I have 5x minus 4x cubed plus 15x squared plus 10. What do you think, based on what we talked about, should be the first term in the expression? Remember, we're putting it in standard form. What should be the first term in the expression? Look at your exponents, and remember the greatest exponent should go first. The leading term, or the first term, should be negative 4x cubed. Following that should be 15x squared. Following that term should be plus 5x. And lastly, plus 10. If you've noticed, the constants always go last. So the expression in standard form should be negative 4x cubed plus 15x squared plus 5x plus 10. With this next example, take a moment and try to do the example on your own. Put the problem in standard form. All right, let's discuss. Oops. Looking at 6y plus 4y cubed plus 11 minus 2y. The first term should be 4y cubed minus 2y squared plus 6y plus 11. My apologies. I thought that I put the next example up, but I did not. All right, try this one. I'll give you a moment to try it on your own. You may pause the video to work this one out by yourself and press play when you're ready for the answer to be reviewed. All right, this is what you should have. Your leading term should be negative 15x to the fourth power minus 8x cubed plus 10x squared minus 2x plus 7. Remember, when arranging an expression in standard form, your exponents must be arranged from greatest to least. So we have 4, 3, 2, 1, 0. As a review, the objective for this component of the lesson is for you to identify the degree of a polynomial and arrange polynomial expressions in standard form with 100% accuracy on checkpoint 2. So as a quick review for the second part of this objective, well, the first part, identifying the degree of a polynomial, look at example 11. Now that it's arranged in standard form, what's the degree of this polynomial? It is 4, because that's the greatest exponent. Looking at example 10, what's the degree of this polynomial expression? It is 3, because that is the greatest exponent present in the expression. And example 9, the degree of the polynomial is also 3, because that's the greatest exponent in the expression. Same goes for example 8. The degree of the polynomial is 3. And the same goes for example 7. The degree of the polynomial is 3. So remember, the degree of the polynomial is the greatest exponent present, and the arrangement of polynomials in standard terms means to arrange the terms, standard form is the arrangement of terms going from greatest to least. At this time, I want you to complete this checkpoint. It says to put the polynomials in standard form. Then identify the degree of the polynomial. I want you to send me your answers in the private direct message on Teams. You may pause the video and complete this checkpoint. You may now take out your workbooks and turn to page 43. Page 43. Follow along as I read the directions and pay attention as I model in completing the directions. All right, it says for problems 4 through 6, evaluate each expression for x is 10. So every time we see x, we're going to substitute it for 10 and evaluate using order of operation. That's a skill that we reviewed last semester. So now it's time for us to apply that skill with this grade level content. So for number 4, we have 6x squared plus 7x plus 2. We need to evaluate this expression for x is 10. So I'm going to substitute each x with 10. So that gives me 6 times 10 squared plus 7 times 10 plus 2. Looking at this term, I need to evaluate using order of operations. So based on what you know for order of operations, should I multiply 6 times 10 first or evaluate the exponent first, 10 squared? What do you think? We're going to evaluate the exponent first. So 10 squared is 100, and 6 times 100 is 600. All right? Now 7 times 10, that's 70 plus 2. Now 600 plus 70 plus 2 will give us 672. So this would be your answer for this problem. Take a look at the next problem. Problem 5 is 8x cubed plus 9x squared plus 4x plus 3. All right, so now we're going to evaluate this expression for x is equal to 10. So what I did here, I substituted x, each x for 10, and this is what I have here. Now I'm going to evaluate the expression using order of operations. So 10 cubed is 1,000, and 8 times 1,000 is 8,000. 10 squared is 100, and 9 times 100 is 900. 4 times 10 is 40 plus 3. All right, now we need to add 8,000 plus 900 plus 40 plus 3. 8. Put our comma in the proper place. The answer for part number 5 is 8,943. Taking a look at example or problem 6, we have x to the 4th power plus 5x squared plus 4x plus 8. Like I did with the last two problems, I'm going to substitute each x with 10. All right, and then I'm evaluating. 10 to the 4th power is 10,000. All right, 5 squared is 100. 10 times 5, that's 500. 4 times 10 is 40, plus 8. Now I need to add that together. 10,000 plus 500 plus 40 plus 8. 8, 4, 5, 0, and my 1. So I have 10,548 for number 6. If you would like, you could pause the video and copy this information down if you were not writing as I modeled. Please make sure you have this down because you can use this as a reference when you do your practice problems today. All right, so this will be your assignment for the day. On page 51, you're going to do numbers 3 and 4. On page 52, you're going to do 5, 6, 7, and 8. On page 53, you're going to do 20A. Page 53, 20A. On page 54, you're going to do parts B and C for number 20. You may begin now completing these problems.